This DB2's Brother Panther. I've got a database here I've been monitoring. I'm going to do a response time analysis for this database, and what I see here is for the last 8 hours, not much going on. I actually want to look at the entire week, so I'm going to look at the performance of this database for the week, and I've got a 1/4 second response time. 85% of that time is inside the database, and the database is a little bit more I/O bound than CPU bound. I'm going to click on that I/O pie slice, and Brother Panther just did the analysis to find the statements that are causing that database to be I/O bound. So right there, I've got about 2/3 of all the I/O in the database tied up in these 4 statements. I can pass those as a workload to the design advisor and apply DB2's advanced index benefit analysis methodology. So here's an I/O bound database, 2/3 of all the I/O in 4 statements. We're waiting for the answer here. Do-dee-doo-dee-doo-dee-doo. Oh, outstanding. And we can see we're going to get from 374,000 time runs down to 116 for a 99% improvement. Here's the indexes that we have the opportunity to create, and we can see the benefit of each of these indexes. If we add this first index, we'll get 49% of that savings. If we add this second index, we get 46% of that savings. And if we add this third index, well, that's not a very big contributor to all that savings. So I take these first 2, that's the bulk of my savings, click on create. There they are in my editor. I'm ready to go. And just like that, in about a minute, I just took 2/3 of the I/O out of an I/O bound database. Isn't that easy? Yes, it is.
All right, well, thank you very much. It's a pleasure to be here speaking with you today, and I appreciate Scott and the sponsors for this opportunity to share some DB2 information that I found very useful. So what we're going to talk about today is anonymous PL SQL block, and that basically came out about version 9.7. And let's take a look. Now here's a true story. It might be considered a horror story, but it has a happy ending thanks to some scripting. So here it goes. All right. As you can see, Junior DBA gets an email alert for disk space threshold exceeded on the test server. So being a good junior, he wants to go ahead and clean up some space. So he logs on to production server. Not good. And he finds some old files, large files, doesn't recognize the file pattern for table spaces, so he starts deleting table spaces of a real critical database in our production system. I don't panic, but Junior thinks about applying for another job or looking for another job, and really I need to recover that database quickly or get to the chopper. So how did I solve this problem? Well, you'll see scripting came in to save me, and immediately I was able to, within a few minutes, launch a restore script that was previously generated, and that saved the day. We were back up in less than, say, an hour, and all was a happy ending. So we're going to take a look at the CLP script, which is something that a lot of people have used before, and then we'll take a look at Corn Shell. And in that script, I'm going to start off little by little in terms of first, what would I put in a CLP script to generate a database restore command? And then I'm going to leverage that script and actually import it into a Corn Shell script and into a here document. So if you're familiar with Unix, and you're probably familiar with the here document, so we'll talk about that. And then it sounds like a big task, but it says let's take a look at scheduling a job to generate a restore database command for each server for each instance using AIX distributed shell, which is DSH. But of course that is a major little bit of a work. So I'm just going to show the results of having something like that, and hopefully motivate you to take a look at how you might be able to automate and simplify your routine DBA tasks and be prepared for events like accidentally deleting table spaces. So anonymous blocks, we can take a look at them. They're in scripting languages, Corn, COP plus. It contains the PL SQL compound statements we're familiar with: insert, updates, deletes, exception handling. And I'm going to use a couple subsets of the Oracle PL commands, set server output, so I can use the DBMS output put line to show my code. So let's take a look at a script. It's very short and sweet. We don't have formal parameters in this language unless I created a store procedure, but I don't want to create a store procedure. So you see I've declared some variables. I have some logic, which I just basically use the sysIBM DB history query to give me the location of the backup and the time that I should restore, use for my backup copy. So there, as you see, I'm just setting some dynamic SQL. And if you execute that, it generates a restore sample database, and then it found the DB2, the output path, the fully qualified output path for the database, and immediately it's ready to go, and I can run that restore database, and I'm home safe and sound. Now what I'm going to do now is say, well, I have corn shells, and I've been using corn shell and Perl for a long time, so I want to basically use that script inside a corn shell. So what you can see here is the complete program, but I'm going to break it up in little pieces so we can see it better. I'm going to go ahead and generate a script. I'm going to take that CLP template, and I basically just cut and paste our CLP script into the corn shell via the restore template file using a here document. It's the same logic as we did before, but now look, if you look a little further near the end here, we got the let's see, right here we have the end of document, and all I have to do to make this script work is to connect to the database, set the server output to on, and then execute the script right there in my corn shell. And just take a look at that for a second. Let me go back one. You see, I was able to leverage the CLP script into a here document, and we know what advantage that gives me is I can use corn shell symbolic substitution and use it to have a parameter into this process, so I can send the database name I want to. So you notice right here I have database name is $, and then I have in brackets DB name. So I pass that to my corn shell program, and that way I have a combination of using SQL and standard corn shell substitution to generate my output. Well, let's see here. And the final thing I wanted to show you is if you take it one step further, I like using distributed shells, and I'm most familiar with the DSH command in AIX. So here's an example of saying, okay, I've got this code built. It's called build restore 3 corn shell, and I'm going to specify a database node. I know it has a few databases on it, so I'm going to run the distributed shell command, and I'm going to say take node C28 mil DB2, execute this store procedure, or not, I mean execute this corn shell, and then I'm going to grep for restore. And so what it does is it goes ahead and really in my main script I connect to every server, every instance, and every database, and every night after the backups are done I generate a restore database command. So in an event that someone should delete the table spaces again, or we have a major disaster recovery or some kind of thing where I need to restore the database quickly, I have it already written. I've got the restore command, I've got the output file, the backup file system, and exact time I need to restore it. I leave open the log target because that might vary by my need. And I think that's a great way of using some of these new features of DB2 and combining CLP and these anonymous block scripts into better managing of databases and creating monitors. And I appreciate your time today. And in summary, it's nice to have anonymous blocks. They're always portable across platforms. And I got to get to the chopper. Thank you.